Hello. Uh, this video is to show you how you will use Ligand Scout to develop Pharmacophore and do modeling using Pharmacophore and virtual screen a large database using that Pharmacophore. Apart from that, you will also learn about to model the Pharmacophore based on the actives and the inactives data, and then generate a rock curve to see how your model performed. So first of all, to start with, to do pharmacophore modeling here in Ligand Scout, uh, you you require first of all Ligand Scout, which is kind of a free. It's not a free tool. The company provides you 1 month license, so you can download Ligand Scout. There are also other tools like Phase, MOE, and Catalyst, which are commercial versions. But this is a pretty advanced tool, and you can do a lot of things like generating pharmacophore, do 3D alignment of the molecules, and then do virtual screening of a very large database. So to start with pharmacophore modeling, you need the 3D coordinates of your SDF file along with some IC50 values here. Uh, then if you have a 2D file, then it's also okay. The file uh, accepts oops, uh, the, the file has accepts lots of SMS files and SDF and in GZ format files also. So once you have a 2D file, you just open that file. You cannot see the molecules on the screen because the screen only shows you molecules in 3D. So you can see the molecule here in this right hand side, the 2D version. To convert it to 3D, what you need to do is to minimize all the molecules with the molecular force field 94 energy. Then all the molecules will get converted into 3D format. You have to select all the molecules before minimizing the molecules. Once these molecules got minimized, you can save the file in 3D format. Then what you need to do, you need to copy all the molecules in the ligand perspective window. Using this widget, copy to other perspective. So this calculation I already did for a set of molecules for malaria data set, and so here you can do a lot of things. For example, this is a very large data set, like 43 compounds. You can ignore some of the compounds which you don't want to model, like for example the high IC50 value molecules, or you want to ignore them and you just want to model with very active compounds. Here I selected around 16 molecules from the 43 compounds to generate the pharmacophore. So here, first of all, to generate pharmacophore, you need to generate the conformers for each molecule. I set it to best settings. It uses omega to generate the conformers for you. Just press the OK button, then it will generate all the conformers and it get listed down here. And then after you generate the conformers, you can click this button, then use the default of pharmacophore fit and atom overlap and merge feature pharmacophore. Uh, the shared feature pharmacophore is it will create the pharmacophore 4 points which are shared by, which is common, like the intersection function which is common in all the molecules. And the merge feature pharmacophore, it will generate pharmacophores for uh, each compounds, and it will show uh, the, the the union of all the compound pharmacophores what they have. So the shared is the intersection, merge is the union. and you can get an idea of which are the important points in the pharmacophore which is required to show the activity. Like suppose for example you have a very active molecule, two or three active molecule, and some of them are like less active, so you can view which point is most important, or which pharmacophoric point is very important to mm, for the activity of the three molecules or so. That's why merge feature pharmacophore, it's sometimes very important. In shared feature pharmacophore, you just have a common point, common pharmacophores of all molecules, and to see which are common in all molecules. So you can apply your custom feature definitions. You can edit the custom features here. So normally a Ligand Scout has the aromatic ring, hydrogen bond acceptor, negative ionizable, positive ionizable, and the hydrophobic and the hydrophobic donor group. You can set this hydrogen bond donor and hydrogen bond acceptor to something using the smarts pattern. So the ID and name and something. So you can make a create a new ID. Suppose for example Lipinski had HPA and just name is Lip. Then you can include the smarts pattern. For this included patterns you want, you just put the smart pattern here, and then also the patterns you want to exclude while searching the pharmacophores. So I'll be using the built-in functions here, and then just press OK. So since you have the 500 phone conformal list, it will take somewhere around 40-45 minutes for this 16 molecule, for maybe 30 minutes to generate the pharmacophores and the fit values. So I have set a model of like 10 to generate, give me 10 models. The score is in range from 0 to 1. Uh, so, the molecule, the score on the model which has a very scores close to 1 means that your model is really good, and uh, it it shows like all the molecules are having this kind of pattern, and how all the molecules are fitting well with the generated merge feature pharmacophore. But sometimes it happens that you need to change the pharmacophore pattern manually, and you want the, the molecules, the patterns based on your hypothesis or something. So this is just a tool to generate the shared feature or merge feature pharmacophore. But if you want to handle it manually, manually means to edit the pharmacophore and or to remove some of the elements of the pharmacophore here. So you just select this. Uh, this is the pharmacophore model, and if you want, then you just mark feature as optional while searching the database. It will take this feature as optional, so you will get more compounds which are non-aromatic at that positions or something cyclic. If you see mark features as disabled, then these features will get disabled and you won't get any aromatic atoms or something based on that pattern. So you will only get hydrophobic, hydrogen bond acceptor, donor, and these groups. Normally around maximum of 5 to 6 points is just enough for defining a pharmacophore for a molecule, but still it varies. You can have 4 points, you can have 5 points, you can have 6 points if the molecule is large or so. But it actually depends upon you how you are trying to model it and what features do you want. So after I generated the pharmacophore, I get a list of the values of the 16 molecules which fits here, and then the conformation for the molecule, number of conformations got generated, and which molecules got fitted. So I created a test and a training set also. So the training and test set can be created like you click some of these molecules, and then you can set the ligand as training set here, and for the test set also just click the molecules you want and molecules as test set. Suppose you want the molecules as ignored. Some of the molecules you see here, I ignored them because I don't want them. They are very high activity values. I will use them in the model validation here in the screening protocol to view the rock curves and everything. So those molecules I ignored here. I only model the pharmacophore based on uh, all the active values and which has very high activity. So once you generate the pharmacophore, you just then uh, copy to the screening perspective here. The Pharmacophore gets copied to the screening perspective, uh, comes here with everything, and this is the result shows here is I did a very large screening of this SNX library around 100k molecules. So to start with generating the raw curves, you need a data set of actives and inactives. So for the actives, I set a cutoff like which are less than 1.4 in my IC50 column. So I extracted those molecules and set those molecules as active. So you need to generate the conformers for these actives as well as the inactives. Inactives are which are more than 1.4, and use this button to create a screening database. The screening database, you need to put in the input file, the actives.sdf file, and the output.ldb file. The LDB is the Pharmacophore Ligand Scout generated database format file. So it contains the conformers along with their uh, 3D information. So input file can be SD, Smiles, or Mol2 format file, and you have to output in .ldb as LDB extension. So remember, once you input the file, it also takes in the different the conformers, number of conformers you want. You can select best settings, you can select fast settings or something like that to generate the conformers and create the database. I have already created a database of actives and inactives here. You can do it from any PubChem bioassay confirmatory screening or any QSR data sets and create actives and inactives. For the inactives, you can use the decoy sets. So mostly people use decoy data sets of particular target. So if you find some decoy sets in the website in the tut.talking.org, you can use that. There are also decoy data sets in the MUV dataset. I'll provide the links of some decoy datasets, and you can use that. Other than that, if the PubChem bioassay lists some inactives, you can use those inactives as your decoy molecules and generate conformers and do the screenings and everything. So first of all, I'll select these two actives and inactives. The red indicates when you select the button again, it gets the red, so it means that it is inactive, and the active is by the green button. So once you click, it is red, and then it's null, then it's green. So once you have a active and a decoy set, this rock curve button automatically shows you here. Then you press this perform screening button. To download the database you use after generating the database, you need to load the database here using your library which is generated, and then it will just show up here in the screening database function. There are also some advanced functions if you want the match all queries and pharmacophore fit or relative pharmacophore fit. The relative pharmacophore fit value shows in values ranges between 0 and 1. So I'll use the default, and maximum number of omitted features is 0. You don't want to omit any feature, you want to keep every feature in your molecule. So for this I selected only the 3 hydrophobic and the 101 acceptor, 2 hydrogen bond donors, and I removed all the uh, exclusion volume from here. The exclusion volume is very important when you do a structure based pharmacophore. So uh, because the exclusion volume contains the steric informations and everything which is required in this structure based pharmacophore modeling perspective. So so aromatic the rings are already disabled, so while searching they won't consider the aromatic ring, and also it will only consider the hydrophobic groups and hydrogen bond donor acceptor. That's it. So now click this button. So it is screening the 42 hits, and it lists you all the pharmacophore values, and once you click the rock curve, it shows you very good high rock performance, and also shows the AUC and the enrichment factor, something like that, and it shows you AUC of 1 to 5%, 10%, and 100%. And the 1% is 100. It means that on screening 100% of the data, on screening 1% of the database, how many actives you retrieved. On screening 5% of the database, how many actives you retrieved. And on screening 100% of the database, how many actives you retrieved. So you can see, like, 34 hits it retrieved from the 42 compounds. So it has 35 actives and 70 coils. So, and also the enrichment factor, the formula is given in the I571 web page. So you can see what's the enrichment here. It's the window is pretty small. Yeah. So once this is done, and so it means that the model identifies the actives and the inactives well, and it can it is it's ready to further screen a large database. So put this thing off and make this thing on, the green button, and then just perform the screening of this large database. I won't do everything. I'll just show you. I will just screen like half of the database, and I'll just cancel the screening on mid of the processing phase, and I'll just show you how the compound got listed and how it got hit, how the hits are generated. See, after a lot of screening here, I listed a lot of molecules. It's still going on screening, and the hits is increasing. It shows you that it takes around 6 hours to complete the screening of this whole database here. So I'll just cancel it and find some molecules here. See, this molecule shows good Pharmacophore similarity on the database hit, right? So this one, yeah, it matches this patterns here. Uh, if you want to tell that you want this patterns to be matched, so or you need only these patterns to get matched, then you can just set that up while you are screening the database using the Pharmacophore, and only those molecules will get filtered. So suppose like this hydrogen bond acceptor here, the donor here is very important. Since there is no donor here and you want to know that this donor, and they want the molecules using this donor, then you can set that up to. In the Ligand Scout, only those molecules will get filtered. So this is how you filter the molecules, and after that, these molecules you just save it, and then these molecules will go for further virtual screening using the docking and all. And after that, we'll go for much more complex analysis. Thank you. I hope you enjoyed the Ligand Scout video of screening the actives and inactives, generating rocks, and screening a large library. I will provide the databases and the screening library of this SNX here, and then you can screen very large databases in your own laptops, and you can generate some good hits uh, from uh, from Ligand Scout. Thank you.